With the development of games, virtual reality applications, a lot of movies, the requirements for detailed 3D objects have exponentially risen. A game with very great user experience often requires thousands of different objects. You can see the sample picture from one of the best games named Sekiro Shadows Die Twice. A single scene may require hundreds of different 3D objects like the leaves and the katana. Currently, these models are designed and textured by experts with digital software like Blender and Autodesk Maya, which requires a great deal of time and expertise. There are no existing pipelines that creating a working environment for artists to work without so many prior experience. So we create our dictation-based scene generation DBSG, a pipeline where users can directly use some text to generate new 3D models, check and modify these models.
Our system adopts DreamFusion to generate 3D models that the database doesn't have. DreamFusion generates 3D objects from a natural language caption, such as a DSLR photo of a peacock on a surfboard. The scene is represented by a neural radiance field that is randomly initialized and trained from scratch for each caption. We use a pre-trained stable diffusion model to optimize nerve via gradient descent, such that its 2D renderings from random angles achieve a low loss. The resulting 3D model of a given text can be viewed from any angle, relit by arbitrary illumination, or composited into any 3D environment.
The 3D key value store uses BERT sentence encoding to encode the text prompts into vectors. This allows us to run cosine similarity on two text prompts and allows us to quantify how similar two text prompts are. Naively, we can just run cosine similarity on each 3D object and return the most similar one, but that won't scale as well. One optimization is to use locality-sensitive hashing and reduce our search space by hashing similar 3D objects to the same hash bucket. Our locality-sensitive hash uses random sign projections, which makes the hash table a probabilistic data structure. We use multiple hash tables and return the 3D object if there is a consensus on all of the hash tables. Here is a visual example of our hash table. If we use a consensus threshold of 60% and 2 out of the 3 hash tables contain our 3D object, we return it. Again, some hash tables might not contain the 3D object due to random chance, as the text prompt and the 3D object might not hash to the same bucket, so we may have to dynamically tune the number of hash tables and the number of hash buckets as more 3D models are stored.
Here's a demo of 2 virtual scenes available to the player, a kitchen and a music studio. Locomotion is enabled, so I can move around in the space with controllers. I can add objects to the scene using voice commands, and live scripts are displayed to provide instant feedback. I'm allowed to recall the generation if I'm unsatisfied with the result. If the result searched by text prompt does not exist in the database, the object will be generated by DreamFusion before being added to the database. I can also edit the color of the object and grab it with one hand or scale it with 2 hands. If I don't need an object, I can just delete it.